Hello, this is Paul from Foresight Tech. In this lecture, we're going to introduce a very important method we call the dimensional analysis to convert the unit. And the last video, I introduced the traditional method, which is a proportion method, right, to convert the unit. And for simple questions, if we only need to convert one step, and for the proportion method, it's easy to do, right? Set up equation, solve the proportion equation, we get the value for the new unit. However, if we have multiple steps, if we need to convert the unit from unit 1 to unit 2 to unit 3, like this, multiple steps, and you can imagine we need to set up a lot of proportion equation to get the final answer, right? Okay, for dimensional analysis, okay, so we can directly do what? We can combine, we can merge different type of proportion equations together into one equation. That's the most advantageous for this method. Okay, in summary, dimensional analysis is the most popular method for unit conversion. And for simple questions, dimensional analysis is the same as the proportion method. However, for complicated questions, you will see the advantages. And in this lecture, I will show you a lot of examples. Okay, so how to do dimensional analysis. And for the first few questions, we were going to practice this method. I will give you the simple. Okay, so it's as simple as a proportion method. And we're going to the later questions. And then you will see we need to deal with complicated questions. And go to that question, so you will definitely see how good is this method. And let me summarize what is dimensional analysis. And is this dimensional analysis? The basic idea is, so first we need to find where we start, which is the original unit. Start from the original unit. And then if we do one step conversion to a new unit, we times one fraction or one rate or one ratio, whatever. And this rate or fraction equals 1. Therefore, we did not change the value. However, when we time these fractions, we can cancel the old unit, and then we can convert it to one new unit. If we have multiple steps to go, all we need to do is just times multiple fractions from the beginning where we start, and then we can directly go to the end where we need to go. And this we call the dimensional analysis. Let me show you the example. And the first example is here. We did the same example in the last lecture when we used the proportion method, right? Okay, so here, I will take this simple example, show you the idea, okay, the complete idea how we're going to use dimensional analysis. And then future and the other questions, I will do a simple version of a dimensional analysis. So these questions, I will do a complete version. Okay, you will see. And usually for dimensional analysis, we have 3 steps. And the first step, we set up a diagram, shows us where we start, where we need to go, and how we can go from the start to the end, show a diagram. The second step, based on the diagram, we can set up equation. The last step, and we just do calculation, do easy calculation, we get the final answer. Let me draw out the steps. So the first is we call diagram. Okay, so let me show. So I simply say is diagram. I will going to draw a diagram for this question. Okay, to set up the problem. The second step is we're going to set up an equation. We will convert the diagram to mathematical equation. So do calculation later. So I simply say this is to set up the equation. And then the third step what are we going to do? Just do calculation. We're going to calculate. And the first was the diagram we need to do. To find the diagram is this. We find where I start of our problem and where we need to go and how from the start to the end. Okay, so where we start. So first, see these questions. If we weigh 180 pounds, how many kilograms do you have? Of course, where we start. So 100 pounds you have, right? This is the start. I simply say, I highlight this where we need to start. So we start at the 180 pounds. Where we need to go is here. How many kilograms do you have? So this is the value of a kilogram is the new unit. This is the old unit. We need to go to a new unit. So this we call it the end. Okay, this is the end where we need to go. And the how from the start to the end. Of course, that we call it the basic relation. Where is the basic relation can help us to convert from the pounds to kilogram is here. Is the basic relation, right? So you know the basic relation. So 1 kilogram is 2.2 pounds. And then let me set up here. Where is the diagram? So the diagram is just like this. So we put the 180 pounds, which is start, right? Okay, I wrote here is 180 pounds. That's the start, and this is the start. Okay, so where we need to go is the end. How many kilograms? So let me write here, like how many kilogram. This is the end where we need to go, right? Let me write it here. So this is the end. We need to go here. Now the middle step is how we can go from the start to the end. And I put the arrow here, which shows that's start, that's the end, how we go. We have to use the basic relation. So where is the basic relation? Is here, this information. Let me draw just a simple arrow. Okay, so we need to use this basic information to convert from start to the end. Okay, so let me write this, we call it basic relation. A basic relationship, that's the information we need. So this is the diagram, and we convert it from start is only goes through one step, right? So these basic simple questions we call the one step conversion. Let me see. So one step conversion. This is the simplest questions. Let me write this box to highlight that these questions is just a simple question, one step. So now we finish the first step. Diagram is here. It's very clear where we need to go. It's go from 180 pounds and go from this 100 pounds to the end is how many kilograms by using this basic relation. Now the second step, set up equation. How to set up? That's the most important. Of course, if we have this diagram, now everything is easy in the second step. How to do? Start from here. So I wrote this as the beginning. I wrote here. We started from 100 pounds. Okay, and the 100 pounds. Can you see this? Okay, 100 pounds equals 100 pounds over 1. Is this correct? Any value divided by 1, we never change. We did not change the value. So this equals this. That's true, right? Good. Why we put this? We just wrote in a fraction. Okay. This is not in the form of a fraction. We divided by 1, and then we have a form of a fraction. This is just the basic usually. And then I will going to times a ratio, okay, or rate, and this rate is equals 1. Can you see? I will going to times which one? I will going to times these pounds. So now we already started from here. And how do you go from pounds to kilograms? I will use this basic relation. How to use the basic relations and make a fraction, which is 1. Okay, and this fraction are already right here. Can you see? I will put the pounds to the bottom, and I will put the kilogram to the top, and then I will see from the basic relation it says 1 kilogram, so I put a 1 here, equals 2.2 pounds, so I put 2.2 here, and I make a fraction. How do you think it is a fraction? 1 pound, so 1 kilogram in 2.2 pounds. It means that they are the same, right? The top equals the bottom, therefore this fraction equals how many? Equals 1. Okay, let me write it down. This is important. We find a fraction. And this fraction, you can say it's a fraction or rate. Usually we say rate. Okay, this fraction is the same. Equals 1 because the top equals the bottom. Okay, the top equals the bottom. And where we did get this fraction from the basic relation. Can you see the basic relation tell us this fraction equals 1, right? Because this fraction equals 1, how do you think? From the beginning, if our time is 1, we did not change, right? We did not change the value. Therefore, from the beginning equal this, that's true. And then now we can do the conversion easily. And these pounds, we don't need the old unit. We have the bottom is also pounds. This is the one we don't need. Can you see? We divided out. See this unit as just a number. We do the same way as we just divided out or cancel. We do cancellation. Okay, cancel this. Divided out these two common factor like a number. Even this is the unit is not a number, we still do the same way. Can you see? If we cancel this, what do we left? And then we left the kilogram. This is the new unit, which is kilogram is what we need. That does make sense? Okay, so now we already set up it correct from the beginning, and then we wrote it into a fraction by divided by 1, and then we times a fraction. This fraction is 1, so we did not change any value. We times the fraction, so we can do cancellation. After cancel the old unit, and then we can get the new unit. Okay, so if we want to cancel the old unit, do you remember? I will put the old unit to the bottom, 1 in the bottom, 1 on the top, so we can do cancellation. If you switch the order, if you flip the fraction, so you cannot get an answer. Okay, and then now we set up. It's easy to set up. And in the future, so this is the beginning, we don't need to write. Okay, you can see. Let me highlight. In the beginning, in the future questions, usually we don't need to write this, which means the dimension analysis is just go from 180 pounds over 1 and then times a fraction. If we need to do multiple steps, we were going to times multiple fractions. Okay, so this setup is the simple. Then the last is going to calculate. Calculate is easy. This is a fraction times a fraction. We know how to do calculation, right? Fraction times fraction is the top number on the numerator times together. The number on the denominator times together. That's the way we need to do. Okay, let me write. And then when we do calculation now, is what? Is this. The top is 180. We don't need to times 1. We can ignore. Okay, times 1 we can ignore, right? So how about the bottom? Okay, or you can say it's times 1, no problem. Then how about the bottom? Bottom is 1 times 2.2. I can say it's 1 times 2.2. Okay, so this we just merge the combine this number times the top together times the bottom together, and then what is the unit left is kilogram. Can you see? So we already canceled the pounds. We left the kilogram. This is the new unit that we need. Okay, so this calculation is easy, right? Use a calculator. 180 divided by 2.2. We can do calculation easily. I get 81.8 kilogram. This is already the final. You remember, so this should be the same results as we used the proportion method in the last time, right? Okay, so now you go back a little bit. So the first step, we build the diagram. Okay, show us where we start and where we end, and what kind of information in the middle step we have to use. If this is only converted one step, that's a one-step conversion. If we have this diagram, and then it's easy to set up equation. To set up, usually we go from here, you can just ignore. So we go from start from here. 180 pounds over 1. Start from here, and then one step conversion is times one fraction, and the fraction is 1 based on the basic relation. And if in your questions you cannot find the basic relation, like this information, you can Google, or for the basic you know the relationship, right? So you memorized it before. Okay, the last step is just do calculation by multiply all the number in the top together, by multiply all the number on the denominator together, and use a calculator to get the final answer. This is the method of dimensional analysis. And look at these simple questions, we still do this a lot of steps. Okay, in the future when you do, you only show this diagram and then directly go to setup and then directly calculate. You don't need to write all these words, so it will be easier. Okay, will be much easier. And here I showed you the idea. Now I will going to do other examples for you. We will follow this, but I will not write like a step 1, step 2, or step 3 like that. And then look at this question. We also did these questions in proportion method. Okay, so how to convert the US dollars to Canadian dollars, right? Okay, now you know what we need to do. And in our method, in dimensional analysis method, find where we start, find where we end, find the basic relation in the middle. Okay, so where we start from the old unit, US dollars. You have these dollars, right? So let me highlight this first. That's all we need. We start from this, and where we go, you have how many Canadian dollars, and this is the end, right? Okay, this is the end. Where is the middle? The middle, of course, see, convert the US dollars to Canadian dollars. This is the basic relation, right? Let me highlight. This is the information we need in the middle. We call the basic steps. Now let me going to draw a diagram, a simple diagram. All we need to do is like this. Go from the beginning, right? So it's 10,000. Okay, US dollars. Let me write the US dollars. Where is the end? Is Canadian dollars. How many, right? So I have a question here. How many Canadian dollars? Okay, how to convert from the beginning to the end? This is our questions. So I will set up here is start, right? We start from this, and we end at here. This is one step. And the basic information, so what the middle is this. Let me show here. That's we call it the basic relation. And how many steps? One step, right? From here directly go to the new unit. That's one step. Let me roll simple is one step conversion. Okay, so this type of questions belongs to one step conversion, which means it's the easiest. And now what do we do? The second step is set up equation, right? We don't need to write this. We directly write this over 1. Remember? So now I will going to start from here. 10,000 US dollars. Okay, but remember this word, divided by 1. Divided by 1. Okay, so this is the start. And I should the reason why we started divided by 1. We started divided by 1. The purpose is just write this as a fraction. When we do calculation, we will not make a mistake. Otherwise, it's very easy to mistake. Okay, make a mistake when we cancel the unit. So this the start. And then what to do? By times the basic information, okay, cancel the US dollars. We're going to the Canadian dollars. So how to do is times, right? Times a fraction. This is very important. How to set up the fraction based on the basic relation, and you need to know where to put the unit. If you flip the order, you will get the wrong answer. See, US dollars is the old. We do not need. We need to cancel. These US dollars is on the top, so we have to put US dollars to the bottom. US dollars, so up here. And then what we need to go? US dollars go to Canadian dollars. So we have to put the Canadian dollars on the top. And then because the unit equals the rate equals 1 or the fraction equals 1, we have to put the number. Where the number US dollars, 1 US dollars. 1 equals 1.35, 1.35 Canadian dollars. Now this the setup. You know this fraction equals 1, right? This fraction equals 1, which means our setup is ready. Now everything is ready. One step conversion times 1 fraction, which is 1, and then we cancel. Okay, the US dollars, we have the Canadian dollars left. If you get this concept, it's very, very easy, right? Okay, now what do we do? Do calculation. Do calculation is merge all together. Let me see. We have this fraction. Okay, the bottom 1 times 1 is 1. Right, the top is this number times that number, so I put is 10,000 parentheses. Okay, I use this parentheses, or you can use this times whatever. Two number times together. What is the unit left is Canadian dollars. Let me also write this. Okay, so now you use the calculator to do multiplication. Of course, we don't need to use the calculator. Directly is how many? See, 10,000 times this is 13,500. 13,500 Canadian dollars, which is the final answer we need. Okay, so now look is easier than the first, right? We don't need to write the steps, and you can make this easier. Okay, the first step still need this basic graph, and set up the second, calculation the third step. And because this is deal with unit, the unit is the most important, because we use the unit to set up the fraction, right? So don't miss this, don't ignore this unit. Just put the unit, put the unit, put the unit, okay, and then do cancellation. And this is the second example, okay. And then I will give another example, and we use this simple example to practice this dimensional analysis method. Okay, later we have complicated questions. You will see it's almost the same as these simple questions. So that's wonderful. Let me see this question. If you read online that there are 15 feet by 20 feet break partial. Okay, so you want to buy something. Okay, but this buy something is based, the price is based on the area. Okay, and the 15 feet by 20 feet, this partial cost about $2,275. This is the price for this product. Now what are you going to do? You're going to buy something. Okay, buy 22 feet by 27 feet of this. Now the questions, estimate the cost. So how much if you're going to buy this area? And based on the relationship, you know, the basic relation is this area has this price, right? So you have, this is the middle information. Let me write something. Where we started for these questions, of course you want to buy something, by how many area is this is the area. Okay, so you have this area to buy, or this area, this product of area to buy. This is the start. Okay, we need to convert this feet by feet to cost, how much US dollars. Okay, and this cost is the end. We need to go. We find the start, find the end. How go from the start to the end is the basic relation. See, that the price. Okay, we had the price, did the price. This is the price, right? So that's the middle information we need. Okay, now let me going to do. We draw a diagram, an easy diagram. Where we start from here, which is 22 by 22 by 27 feet by feet. We usually write the feet square, right? Okay, square feet. So we wrote the square feet. And then where is the end? The end is how much US dollars, right? So I will going to put a question mark here. Unit is this dollars, and they go from the beginning to the end. And then let me see, this is the start, right? This is the start, and this is the end. Where is the middle? The middle is their information. Let me put it there here. Okay, see, we use this basic relation, put it in the middle. From the start can go to the end. From square feet we can find how much dollars, how many dollars, right? That's how many steps. Of course, completed one step. That's a simple one step conversion. You say this is the simple questions, one step. That's the first step we set up. Okay, we draw the diagram, and then our going to set up is the same. So this number over 1, right? Always 22 by 27 square feet over 1. Okay, and then where is the fraction? The fraction is based on that. So you need to know where to put the unit. Usually we put the unit first. You see, and the square feet we don't. So I put the square feet to the bottom because I was going to cancel, right? And the dollars we need to the end, so I put the dollars on the top. Let me simply put the dollars here. What's the relationship between this? Is 15 feet by 20. Let me write here 15 by 20, right? 15 by 20 is the bottom. Equals how many dollars? Is 2,275 US dollars. This you cannot say is equal, but we say you use these dollars can buy this kind of product. Usually we call it equivalent. So this fraction is the equivalent to 1. Okay, which means if it's equivalent, it's the works for dimensional analysis. So don't worry, you just see this equal this, no problem. And we set up now. How to do calculation? Cancel. Okay, we cancel the old unit. I will going to get the new unit. The calculation is simple. Now, the last step, to put all the top together, put all the number on the bottom together. Do calculation. Use the calculator. Okay, and is this? Let me write down a little bit longer. So this number 22. I still use parentheses. Okay, times 27. Parentheses times this number 2,275 parentheses. Okay, the bottom I ignore this 1 because 1 times any number is the same. And then we have 15 times 20 on the bottom. What is the unit? We have one new unit left, which is the dollars. See, and then we're going to use the calculator. And this number times this number times this get at the top. And this number time together we get the bottom. Is the top divided by the bottom to calculation, right? Okay, so how much I get? I get this dollars, $4,504.50. Okay, so this is the final price. This is the final cost that we need for this question. Then now you think And this is much simple. Okay, so all we need just find the basic diagram and then set up the equation and then do basic calculation. Now let's go into two-step problem. But you will see the advantage of this dimensional analysis, even for these a little bit complicated questions in 2 steps. Let's read this question first. Your car gets 24 miles per gallon of gasoline, and you drive at the average speed of 45 miles per hour. How much gas do you use in 2.5 hours? If everything follow this information, and they're rounded to 2 decimal places. How to do? It's still the same, right? Find where we start. Not start from this number, not start from this number. Okay, all this is the middle. We start from here. Okay, we start from 2.5 hours. Why? That's what you need to do. You need to go by this time. Okay, so we set up this is the start, and this is the start, which means the old unit is hours, right? And then we have to go in these hours. How much gas? How many gallons? Or you can say is how many gallons of the gasoline is not dollars. Okay, how much gas do you need? Is this? Okay, so here is the end. I set up this is the end that we need to go. Where is the middle information? Go from hours to how much gas? Can you think? This time we cannot finish in 1 step. We have to do in 2 steps. Why? Imagine. Did the start? Can you see the information? Hours can go miles. This information is for miles. So the first step conversion. How many hours ago you can? How many hours you can go? How far? Okay, and then another is miles can go. How many gas? How many gallon of gasoline? Which means 2 steps. I have to write it down so you will see. From the start to the end, this time we cannot finish in 1 step. We have to do in 2 steps. Okay, still wrote the diagram. Start from 2.5 hour. Let me write 2.5 hour is the beginning. Whereas the end, let me write here. The end is how many gallon of gasoline. I will put like here, and how many gallons of gasoline. We cannot go from the beginning to the end. This is the start. This is the end. But we can find a strategy. From start, we can go to the end. By what? By put something in the middle. See, I put how many miles in 2.5 hour you can go. How many miles you can go? You can imagine. I put here how many miles you can go. Of course, I know how many miles I can go. Why? Can you see? This is the first step conversion. Because we have this information. Each hour I can go 45 miles. Therefore 2.5 hours I can go like 25 or more than 100 miles. Okay, so let me see. This is true because we can use this information. Is what the information 1 hour equivalent to 45 miles is 1 hour equivalent to 45 miles. I put this information here. See, and this is the basic relation. Of course, this is equal, which means equivalent. Okay, because of 1 hour you can go 45 miles. That's the information. Therefore, we know 2.5 how far or how many miles we can go. Right? Now it's good. We finished the first step. The second, if we know how many miles we need to go, then how many gallon of gasoline we need based on what? This information. The first we already used. This we already used. Now we're going to use this information. See, 24 miles, we need to use 1 gallon. And we know how many miles we need to go, so I should know how many gallon of the gasoline we need. That makes sense, right? Okay, now I did the second step because we already goes to miles. So miles go to gallon is this. Okay, I put here. Let me put this information here. How do you say is 24 miles, right? So 24 miles equivalent to 1 gallon of gasoline. Equivalent, which means 1 gallon of the gasoline you can go 24 miles. Now how many miles you need to go, so you can find how many gallon of the gasoline you need. Okay, and did the second. Can you see now you merge them together from the start? So 22.5 hours we can go how many miles we need to go. And then from the mile, the second step, how many gallon of gasoline we need, right? That's look as normal. Okay, good. This is the diagram. Give us all the information from start to the end, including the middle steps. What kind of information we need, basic relation, all from the question. And then let me put it here. This time is different. How many steps? We need to go 1 steps. 2 steps. 1 step times 1 fraction. 2 steps times 2 fractions. Okay, that's 2 steps conversion. This we call 2-step conversion. And then the second step, we're going to set up the equation, right? So go from here 2.5 hour. I think now you know how to go, right? Write this first, and then times 1 fraction based on this information, so we can go miles. And times the second fraction of 1, we go to the last unit. The first unit 2.5 hours, so I put 2.5 hours. You remember, over 1. Okay, and then write the unit fraction, and then times another fraction. Hours go mile. How to do? How to use this information. I know you should get the information already, right? So it's this. Hours up here because we don't need. Miles up here because we need. And then what the relation? 1 hour can go 45 miles. Okay, if you cancel these hours, so now 1 step we already go to miles. We do the second step. How do you go from miles to gallon? It's times another fraction. And mile we put it to the bottom because this is on the top, so this should be put at the bottom. And then gallon is what we need, so put it on the top. What's the relationship? Is 1 gallon for here equals or equivalent to 24 miles, so put it 24 miles. So this fraction is equivalent to 1, these fractions are equivalent to 1. Okay, and can you see now I can sort the miles. What is the last unit we get is gallon, which is the new we need, right? The last step is to this. It's just do calculation. So we put everything together. What is on the top? 2.5 parentheses I use. Okay, times 45 miles. Times 1 you can ignore because times 1 means nothing. What is the bottom? 1 times 1 times 24, which is 24 is already. Okay, and so the unit is gallon, right? It says. Then now you do calculation, use your calculator. This number times this over this, I get 4.69 because it asks 2 decimal. How many? What the unit? Gallon. Which means what? Well, finally 2.5 hours. I know I will use this kind of gallon. So if we, you know the price of the gasoline, I probably can guess. Okay, I can estimate how much money I need to pay for this gallon of the gas, right? Okay, so this is a question. Okay, even this is 2 steps. You can imagine. You can just go over a little. See, the method is still the same. The step is still the same. almost as simple as the first simple question, right? No matter how many steps we need to go. Okay, probably take a little bit of time. I'm going to draw the diagram. Okay, so you find everything clear. The diagram just help us to think about all the problem clearly, all the steps. If we make this clear, and then the second step is much easier to write, and then the calculation is the simplest. Okay, so another question, so we move. Now look at this question. We're going to convert. You look at a lot of number, so this is also 2 steps. Okay, let me highlight. Now I will go a little faster. Convert this unit to that unit. So convert, which means this is the start, right? Older unit. We start from here, and then to liter per minute. This is the end because the questions ask what's the relation. Of course, you know this is the middle relation, but we have a 2 relation, which means we have to go 2 steps. Now I set where is the beginning. Here is 2.4, right? Gallon per, which means I wrote it into fraction, per hour, which means in 1 hour. See, that's the beginning. I mean, wrote this is a start. Where we need to end. So I mean, end here. End is how many new unit. So how many? I put a question mark here, and there is liter per minute. Can you see? That's the final unit. That's the old unit, the new unit. Now how to do conversion, how to use this basic information, 2 steps. The idea is simple. Gallon, we can go liter. See, gallon and the liter, we have a basic relation. So we simply say it is, we can convert gallon to liter. Okay, on the top we convert it first. The basic relation is there. Our rod here is 1 gallon equals 3.785 liter. That's the basic relation. Therefore, by times 1 fraction, we can convert a gallon to liter. The same idea. The second step, I convert hour to minute. Everyone knows, right? You don't need to look at this information. And we're going to convert the second step, which is hour to minute. The relation is 1 hour is 60 minutes. Okay, so this is the diagram. And here is very clear, tell us everything. Where we start, where we go, what's the middle, and how many steps, or 2 steps, right? This is a 2-step conversion question. This type of question. And then we're going to set up the same. Okay, this is the beginning. Do we need to divide it by 1 again? No, it's already have 1 here. Okay, so we just wrote. So 2.1 gallon over 1 hour. This time we already have a fraction at the beginning, so that's good. I do the top first. It's okay. I convert a gallon to liter. How to? Times 1 fraction. What is the fraction? See, gallon, I have to cancel. I put a gallon here. And the liter, I need to go. I put the liter there. When we cancel this, we get a liter, right? What the relation, basically 1 gallon, so I put a 1 here, equals how many? 3.785. Okay, so this is the first fraction. Of course, this equals 1, right? And can you see we cancel gallon? We converted the top to liter already. Now I'm going to convert the bottom. Please pay attention. Convert this bottom to minute. Can you see what kind of fraction we need to use? Where to put the hours? Do we still put the hours on the bottom? No, because this time the hours is the older unit we need to cancel, so I have to put the hours, put it on the top, because in this way we can cancel, otherwise we cannot. This is the basic rule. And then I put the minute on the bottom. Can you see this minute we need is on the bottom, so I put it here. That makes sense. Consistent, then I put the basic relation is 1 hour equals 60 minutes. This equals 1. Time is 1. We did not change anything. And then what do? We cancel this hour and this hour. What we left there is liter per minute is exactly we need. Can you see? This is 2 steps. You can imagine if you use the proportion method, what to do? You have to set up 2 equations, okay, 2 proportion equations to solve. However, the dimensional analysis, now we see exactly what is the advantage. Just merge a lot of steps in one sentence, okay. Now, what do? Calculation. You know calculation is easy, right? It's just this. Okay, that's a piece of cake. Put the odd number on the bottom, which is 2.4, 3.785 equal to 1. What's the bottom? 160 times together is just 60. Okay, and then what the unit is liter per minute. That's the one. Can you see? That's the one the question asks. The new unit we need, and then use a calculator to calculation. See what we get. Round it to 2 decimal. Okay, I get a 0.15, and the liter per minute is the new unit. That's the answer. And I have a few other questions. I hope you already get the basic idea. I hope you already see, okay, why this method is the most popular method. Okay, see these questions. This time we need to convert what? The current gasoline price in Winston-Salem is 1.99 US dollars per gallon, and it is this number in Beijing and China. Okay, that's Chinese yuan per liter. The unit totally different, and the currency they use different. Okay, which one is cheaper? We need to answer these questions. We will meet this kind of question if we travel to other country. Okay, if the price change, the currency change, you need to compare what is the price, right? So this is a normal question. Relations is here. Now, how to do this? We have 2 ways. Okay, you can convert this Chinese yuan per liter, this unit, to US dollars per gallon, to the unit that we are familiar. Or you can convert this unit dollars per gallon to Chinese yuan per liter in China, and then you can compare. Otherwise, we cannot. So I was going to convert this not familiar and to the US dollars per gallon, so that we know. So I said I know I go from here, right? Because I want to convert this to here. So I go from here. So this is the start. Okay, we start from here, and then I will going to change it to this unit. This is the end where we need to go. So what is the middle step we need? Of course, this is the basic information, and this is the basic information. We have 2 basic information, 2 steps. Let me draw diagram here, where we start from there. I will going to put in this way a fraction, which is 6.73 Chinese yuan. Okay, use this. This is the symbol for the Chinese yuan per liter. I'm going to write per liter is 1 liter. See, this is the price in China. Okay, so up here is the start where we need to go. Let me put it here. Okay, so put a question mark. I will change this price to the price that we know, which is how many US dollars per gallon. How many US dollars? I use this symbol, and per gallon, which is 1 gallon, or just put a gallon. Can you see? I need to convert this to here, and then we know, and then we can do comparison, right? Should be 2 steps, the same as the last questions. Converted the top, converted the bottom. If we converted the top, is this. The top is what? is Chinese yuan to US dollars. What is the relation? Relation is here, right? Let me write that one more time. Is 1 US dollars equals 6.92 Chinese yuan. And then we'll convert at the bottom is liter to gallon. Look at this. How to convert the liter to gallon? The relation is here. 1 gallon equals, okay, so we can write 1 gallon equals 3.785 liter. Okay, so from the liter you can go gallon easily. And this is the start, of course. This is the end where we need to go. So there are two steps. There's a 2-step conversion. Okay, now what are we going to do? You just set up, right, at the beginning. So I set up 6.73. This is Chinese yuan per the 1 liter. And then the first step I will going to convert at the top. And the Chinese yuan to US dollars use this relation. So set up a fraction. I have to put the Chinese yuan here because I want to cancel. And then I will put the US dollars there. The relations put $1 equals 6.92 Chinese yuan. Okay, and then if we cancel this, see the top already goes to the US dollars, and the second step convert at the bottom. Okay, convert at the bottom. The bottom is what? I have to times another fraction. It's the same. This liter we don't need, right? So keep in mind, be careful about this. I have to put it here because I want to cancel. Okay, 1 on the top, 1 on the bottom, we can cancel, otherwise cannot. And then gallon is the bottom we need to go. What's the relation here? 1 gallon per here. 1 gallon equals 3.785 liter. This is 1. This is also 1. So you times 1 is still the old. So the value is not changed. Let me cancel this liter. Can you see? And the new unit is dollars, US dollars per gallon. And the last step just do calculation. It's easy. Right? The last step is the easiest. All we need to do merge the number. So which is 6.73 times 1 I ignore times this times 3.785. What the bottom is only one number because times 1 we can ignore. What the unit is US dollars per gallon, and do calculation 3.68 and US dollars per gallon. This is the answer. What do we get? Can you see? And now let's look at another questions. And these questions is related to the health issue. Okay, which means this is very important. We do drug or dose analysis or dose calculation. If someone, you are a nursing student, or you are a nurse, or you are in the nursing program, so these type of questions is very, very important for you. Please try to use this method. It is very easy to solve these questions. Can we see the last 2 questions is just for nursing student. Can you see this? And the doctor orders a drug 6 milligram by mouth as needed every 4 hours. Did the information. And the dose is here, right? The dosage is 6 milligram of the drug. And then what do you have? You see, if you are nursing, you need to administrate is his. What do you get? You get is not directly the drug. The drug is in the liquid, right? So the concentration is here. Every 15 milliliter of the liquid has 7.5 milligram of the drug. This we call the concentration, which means what? Now you get a liquid. See, the question is how many tablespoons will you administer per dose? The dose is there, right? Which means Finally, the question asks you, you are going to administrate is, okay, to use how many tablespoons. You have to calculate it by yourself. How? The beginning, now we see these questions, okay. It's the same, use dimension analysis is super easy. The same you can think about it where I started. You have to administer one dose, which is the start, right? This 6 milligram of the drug. This is the start. Where is the end? Can you see the questions? How many tablespoons? This is the end. You finally need to know how many tablespoons you need to administer and the dose. So what is the middle? Of course, the middle we have see one information, two information. This is the information. This is the information. How to use the information? So the best is draw a diagram, so we will see it clearly. We see draw a diagram. Started. There's the dose. Let me go from here, and this is the beginning. So I simply wrote here is 6 milligram of the drug. I ignore that drug. That's the beginning, right? And what is the end? So the end I put that here is how many tablespoon. Okay, I use this simple, and this is the start, and this is the end. We need to solve the questions by this way. So you know we need to put something in the middle. Okay, how is this 6 milligram of the drug? See, you will know how many milliliter of the liquid you need, because it tells us the concentration. So how many drug you need, then you can find how many liquid you need, which means how many, I put it in the middle, is I know how many milliliter of the liquid I need. Why? Because we have the basic relation. See, and I'll put here to here. That's the basic relation tell us 7.5 milligram of the drug in 15 milliliter of the liquid. Therefore, 6 milligram of the drug in how many milliliter of the liquid? Of course, we need to know. And later, I will going to do just times a fraction. You don't need to exactly use the proportion. Of course, if you set up a proportion, is good. See, you set up a proportion here and then set up another proportion equation there. You need the two equations. Okay, but dimensional analysis, we only need one setup. This is the advantage. How about the second step? So now you have the new unit, which is milliliter. The last step, milliliter, goes to how many tablespoons? I think you know, because 14.8 milliliter is in 1 tablespoon, and then do this calculation is the normal times a fraction of this. You know how many tablespoons. So finally, 2 steps, so you can get the answer done. Get this question up here. Can you see? Go over a little. This is the diagram. So 6 milligram of the drug, we know how many milliliter of the liquid based on this information. And then based on this information, we can convert the milliliter to tablespoon. 2-step conversion. I put here is 2-step conversion. I hope you get it. If you are a nursing student, do you think this is helpful? And after this example, I have another example. We have a lot of steps. We have 3 steps, but it's still the same. Okay, idea is still the same. The method is also the same, all consistent. Now, what are we going to do? We wrote the 6, right? We wrote the 6 milligram is the beginning over 1. We wrote it into a fraction. So convert it to milliliter. How to do? Times a fraction. And the milligram, we want to convert. We want to cancel, so I put the milligram to the bottom. And the milliliter we need, so I put the milliliter here. What is the relation? There, which means 15 milliliter. 15 you have to put it to the top, because it's a 15 million liter of the liquid has this kind of a drug, so we put the 7.5 to the bottom. This fraction is 1 or equivalent to 1, so you did not change the value. Now we cancel the milligram. What do we get? We already get a million liter, right? So one more step. Can we times? How do you go to tablespoon? Is here. Million liter, we don't need to put it at the bottom. Tablespoon, we need to put it to the top. And what's the relation here? 1 tablespoon, we have 14.8 milliliter of the liquid. That's 1, okay? The other fraction also 1. Now you cancel the milliliter. What's the final? The final unit is a tablespoon, which means you can find how many tablespoons you need by calculation. Now I will go to calculator. Calculator is just easy. Times all the number on the top. 6 times 15 times 1 you can ignore. The bottom is 7.5 times 14.8. You can ignore this one. And the unit is tablespoon. Can you see? Okay, now do calculation. If you use a calculator, you get 0.8. Just around the 0.8 tablespoon. This is the result. And I hope you get something from this type of method. Dimensional analysis works very, very easy, okay? Look at the last questions we are going to do. We are going to deal with 3 steps, okay? More than 2 steps. And if you meet multiple step questions, still the same. Follow the 3 types. Draw a diagram, set up your equation, do calculation. How about these questions? Okay, this question is still we're talking about the dosage. Okay, it belongs to dosage calculation for nursing student. So this is really important. Okay, so we cannot make any mistake when you do calculation. I know everyone knows this, right? So how do you do? Set up. All we need to do is find out where we started, where we need to go, what is in the middle. And this is a drug. This drug is in this form. Milligram of the drug per kilogram. What is kilogram? Let me see. It's ordered for a child. For a child weighed 74.8 pounds, which means what? And this kilogram, which means 1 kilogram is the weight of a child. This number, which means 1 kilogram of the child need 1.5 milligram of this drug. That is the dose. So you know what that this unit mean. And now the child is weight 74.8 pounds. Okay, you know. But this is the unit are different. Now we have other information. This drug is available not in the solid. Is in what? 125 milligram of the solid drug per 2 million liters. So this is still concentration, which means the drug is dissolved in a liquid. That's a concentration. So now the question is how many million liter? Look, it's complicated, right? How many million liter must the nurse administer for this child? Now it's there, you are going to do the job. Okay, it's going to administer this dosage that your doctor gives to you. How to do the question? So let me going to set up and be patient, don't worry. Start from what? From the dose, right? So find where we start from the dose. Okay, you can start from the dose or you can start from another. Imagine I started another. I will not start from there. I will start from the child because you deal with the child, right? Or someone you can think you deal with this dosage, no problem. But the easiest way, I start at here. You will change it by yourself. Okay, if you want to try. I will start. I will going to administer drug to this child. So this is the start point for me. This is the start. Where we need to go is easy to find. How many milliliter? Can you see this? Of course, this is the end, right? We need to know how many milliliter of the liquid containing drugs I need to administer. Whereas the middle information, I will not highlight. All this information we have. Okay, I highlighted 1 information, 2 information, 3 information. That's the middle. Okay, so how do you organize your middle information? So what we need to do is draw a diagram. It's not so complicated. We just follow. Start from there, go to end. How many steps? I mean, draw the start and draw the end. We will going to explore what is the middle. Start from this chart, which is I will going to write here 74.8, right, pounds. What is the end? I put the very, let me see up here. How many milliliter of the liquid we need to administer? Let me write that this is the start, this is the end. Okay, so how many steps we need to go? I don't know. I have to look at the information. First, you think, and this is the weight of the child. Pounds. Pounds cannot link to this unit, cannot directly link to the drug, because which one linked to the drug is kilogram of the weight linked to the drug. So you can imagine, pounds we need to convert to kilogram first. Otherwise, I don't know how many milligram of the drug I need to administer. So the pounds can go to kilogram. We have the information here, right? Okay, see, pounds can go kilogram. Let me write this somewhere. I wrote it here. Okay, so I can go how many kilogram of the child. Okay. And how to use the information is here already, so I directly put the arrow, which means what? The child, I will know how many kilogram the child has. Now I know what 1 kilogram of the child need this drug, so how many so I will definitely know how many milligram of the drug. The next step, convert kilogram to milligram of the drug. Right, let me write it down. I can convert it to this milligram. This milligram is better. I put a little bit more information. Put it S. What does it mean? This S means the drug, the name of the drug. And I know how many kilogram of the child, so I will know how many milligram of the drug the child need. Okay, so now this is the second step. Where is the information? So I have to write down the information. Let me see. What is the information? Information there, right? Okay, this information gives us this. I wrote here is 1 kilogram of the child. This is of the child need equivalent to 1.5 milligram of the drug. And I put the information here. Okay, so now the second step, we convert the kilogram to milligram of the drug. The last step, if you know how many milligram, do you know how many milliliter you need? The information is there. The concentration of the liquid. Okay, the last say is the concentration of the liquid. All we need to do now is do this. Okay, and we know I put the information here. So we see. We take a little bit of time. I put the information. Milligram of the drug, 125 milligram. Let me write 125 milligram of the drug equals or equivalent to 2 milliliter of the liquid, because this drug is dissolved in this liquid. That's the concentration. I put this information to here. Now we finally, now let's go over a little. You know how many pounds of the child and easily to convert. We know how many kilogram of the chart. Then we will know how many milligram of the drug based on this information. And then based on the concentration, we will know how many milliliter of the liquid you need to administer. Does it make sense? 1, 2, 3 steps we have to do this time. Okay, so we call the 3-step. These questions look a little bit complicated, but the steps they are the same. Now I get the diagram. Okay, the diagram is very clear to tell myself I need to go the first step, the second step, the third step. Now I will going to write down the steps. Just set up the equation. Or someone you can imagine, if you use the proportion method, see, this go to here, set up a proportion. This go to here, set up another proportion. This go to here, set up another proportion. How many proportion equation? 1, 2, 3 proportion equation you need. That's too complicated. Of course, that's why this method is the most popular for complicated question. So now I am going to just set up at the beginning. So 74.8 pounds over 1, right? And then I will going to times what? The first convert the pounds to kilogram. So I put the pounds here. I put the kilogram on the top. And I will put the relation is there 1 kilogram. Put the 1 here. Equals 2.2. So 2.2. Put it here. And we cancel the pounds. Now we get we goes to this unit. Okay. And then what? Okay, our times. The second step, convert the kilogram to this drug. So I have to put the kilogram here because I want to cancel, right? And I will put the milligram of the drug, put it there. The relation is here already wrote. 1 kilogram of the chart need 1.5 milligram of the drug. Okay, that's the basic relation. You know this fraction is equivalent to 1. Still works for dimensional analysis. So cancel this kilogram, and then we're going to here step by step. The last step go to there is the last fraction times you have 2 times milligram of the drug goes to milliliter of the liquid. Relation is there, so it's 2 milliliter of the liquid has this kind of drug 125. And if we cancel the last this unit, can you see? Okay, so what do we left? We left the milliliter of the new unit. That's what we need. The last step, the easiest. We're going to convert all these numbers together. The top is 74. This should be 74.8, right? Pounds times 1.5 times 2. That's all the number. And we have milliliter left. So what is the bottom? This ignore. This one ignore. 2.2 times 125. So 2.2 times 125. See, that's all we connected. All the number that we connected. And do calculation. In the calculator, I will get the exact number is 0.816 milliliter, or approximately. Okay, that's the final. How many milliliter you need to administer? This one is around like 1 milliliter, a little bit smaller. So we have an exact idea what to do for yourself. That's all. Thank you.